Welcome to Nano Matters, the podcast that explores examples of nanotechnology. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Here with me today is Nanshu Liu, Associate Professor in the Department of Aerospace Engineering and Engineering Mechanics at the University of Texas at Austin. So, Nanshu, can you tell us a little bit about wearable sensors?
Sure. Our human body is just like a soft machine, right? Like any machine, like a car. So we are continuously radiating highly personal, multimodal, and distributed data from head to toe due to our motion, our brain or cardiac activities, our biochemical reactions going on inside our body. So wearable sensors are really just any kind of sensor that picks up electrical, mechanical, thermal, and even chemical signals from the surface of the skin in a non-invasive manner. So state-of-the-art wearable devices, they are really exploding right now.
So I've seen some images of tattoos or sensors that go directly on the skin. What types of things can these tattoos measure, and how is nanotechnology playing a role?
Yes, we are one of the early pioneers, e-tattoos. So e-tattoos are hair-thin, skin-soft, wearable patches that can be adhered on human skin like a temporary tattoo sticker. They are highly multifunctional, wear and forgettable, and can wirelessly stream real-time vital signs to our smartphones. I have been working in this area for 16 years, and we have to co-design the circuits with the geometry layout and to incorporate different nanomaterials for their superior electronic performance like conductivity, mobility, transparency, and atomic thickness like graphene. And we also develop digital manufacture process, and we validate our electronic tattoos.
I like the expression you used, wear and forgettable, because I think that some of the medical sensors that are uncomfortable, especially for long-term monitoring of heart rate, or patients will take them off, or that they won't comply with monitoring because they're uncomfortable. So the wear and forgettable seems like a really important attribute.
Exactly. And also there's something called a white coat syndrome. So when we have conscious awareness that we are being monitored or we are being checked by a doctor, our physiology changes. It's no longer the most natural physiological activity. So only when we can have completely unobstructive and wear and forgettable, mechanically imperceptible sensors, then we can monitor the most baseline natural status of our body. And there is also something we use graphene to make, which are even optically imperceptible. You cannot see them. And they help with battling with the social stigma, because for patients, they don't want to let people see that they are wearing a lot of cardiac sensors or brain sensors. So that's another area we're trying to look into a little deeper.
You mentioned heart rate. What are other biometrics that you can measure and monitor with these tattoos?
Yeah, so our body is full of multimodal signals. For example, electrical signals are on the surface of our skins. They are called biopotentials. On the brain, it is called electroencephalogram, EEG. On the chest, it's called electrocardiogram, ECG. On the muscle, it's called electromyogram, EMG. So we have to put the tattoo at the right location. In addition to electrical biopotentials, we can also measure mechanical motion and also skin deformation, like joint bending. And even on the chest, if you put your fingers, you can feel your heartbeat. That there is a mechanical signal from the heart. It is called a seismocardiogram, SCG. So those are mechanical signals. And we can also, of course, measure temperature, thermal signals, and we can use micro LEDs to measure reflected light or transmitted light. Those are called PPGs, photoplethysmography.
And are you able to measure oxygen content in the blood using optical techniques like that?
Yes, so that is based on different wavelengths PPG signals, and we can extract blood oxygenation either from the capillaries, the peripherals, or even from the arteries.
I want to thank you again for taking the time to talk with us about your research. This is really a fascinating and important area. Do you have any closing thoughts that you'd like to share with our listeners?
Yeah, I want to mention that ETA2 technology is still in its infancy, and there are still a lot of challenges, and one of them is charging. Long-term powering, and we are trying to develop wireless charging strategies to solve that. And we need flexible and soft batteries, energy storage devices. Currently, the most rigid space-consuming component is battery. We are exploring piezoelectric stretchable tattoos that can generate reasonably useful energy for just charging. It cannot just completely power the tattoo. But there are also many other researchers working on using sweat in fuel cells to power wearable devices or using body heat. Those are all possibilities. And nanotechnology is playing a key role.